In this video, we're going to talk about scientific notation. Now, scientific notation has two main purposes. First, if you have a really large number like this, or a really small number like this, it's hard to write out these numbers in their full forms. It's a lot of digits. So with scientific notation, you can express these numbers more concisely. This represents this large number. This represents this small number. Another use for scientific notation is that it makes it easier to show the number of significant figures in a value. So take this value, for example. If you know the rules for significant figures, you can count them. You can examine this to see that the leading zeros are not significant. The trailing zero is, and so there's 3 significant figures. But in this form, many people think that it's easier to quickly examine that there's 3 significant figures in this number. So how do we write a value in scientific notation? Here's the official definition for scientific notation. A number expressed in the form a times 10 to the n power, okay, where the a value, the absolute value of the a value, is greater than or equal to 1 and less than 10. And n is an integer. In that form, you have scientific notation. So this absolute value of a being greater than or equal to 1 and less than 10. That just means that for any scientific notation, if we look here, you can have a decimal, but you're going to have a single digit before the decimal, not including 0. In scientific notation, you won't have just a 0 before the decimal, because that would be less than 1. You can have a 1. It can be greater than 1, but then it can't be 10. You can't have 1 0. You see, so it's a single digit before the decimal. And then it says the absolute value, because you can have a negative number. It doesn't have to be literally between 1 and 10. It's the absolute value. So a single number before the decimal point, if there is a decimal point, and you can also put a negative if you want, a negative out front. And then the power of the 10 is an integer. So an integer is a negative integer, 0, or a positive integer. That's scientific notation. So let's work some examples. How do we write this in scientific notation? Okay, so the decimal place is here. So 1, 2, 3, 4, 5. We want to come here because we'll have 3.5. Okay, times 10 to the what? We went 1, 2, 3, 4, 5. Times 10 to the 5th, right? Because if you multiply 3.5 times 10 to the 5th power, you get this. Now we can't say 35 times 10 to the 4th. That's technically not scientific notation. Why? Because 35 is greater than 10. And similarly, if we did 0.35 times 10 to the 6th, that would be less then this value would be less than 1. So this is the correct scientific notation. Okay, so the starting value is going to be between 1 and 10, so we're going to have 2.71. Okay, now times 10 to the 1, 2, 3, minus 3. Right? If we multiplied 2.71 times 10 to the minus 3, so times 10 to the minus 3 means we're dividing by 10 to the 3rd. You could write this as 2.71 divided by 10 to the 3rd power, so that means that the decimal is going to go this direction. And this is between 1 and 10, so that's our answer. 86. This is just for practice. I think in actuality, you might just leave this as it is, because there's no reason to write it in scientific notation. It's actually more complicated. It depends. It depends if you find it might be easier to clearly show the number of significant digits, then maybe you want to write it in scientific notation, but they just want us to practice here. So, okay, 86, we need to make this number, the starting number, between 1 and 10. So 8.6 times 10 to the what? To the 1st power. You see? This is the scientific notation representation of this number. Okay, we want to write this first number between 1 and 10, so 7.92 times 10 to the minus 1. This is the scientific notation representation of this number. The speed of light is approximately this value centimeters per second. So we're just going to write these values, these physical values in scientific notation. Okay, so it might be tempting to put 29.98 times 10 to the something, but 29.98 is greater than 10. You need to put 2.998. You might say, well, do I put a 0 here? Maybe. This would be a significant figure, and we're going to talk about significant figures in another video. But as far as just practicing scientific notation, you could put a 0 if you want. You could leave off the 0. It doesn't matter. I'm going to leave it off. Okay, times 10 to the what? So it's going to be a positive integer because our actual number is bigger than 2.998. Okay, so our decimal point is starting here. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but now put what this value means something in this problem. Okay, the size of an HIV particle is approximately 0.00001 centimeters. Okay, so 1. And remember, scientific notation, it can be greater than or equal to 1. You can put 1. It's just about having a single digit in front of the decimal place if you have a decimal place. Okay, 1 what? 1 times 10 to the, so 1, 2, 3, 4, 5, minus 5. Because our actual number is smaller than 1. So we're going to be multiplying it by 10 to the minus 5, or in effect dividing by 10 to the 5th. All right, centimeters. Okay, now this is not a video on significant digits, but I guess technically the correct way to do this would be to count the number of significant digits here and apply that in your scientific notation representation. So here there's 1 significant digit, so you leave this as 1 significant digit. You wouldn't put, that would be 2 significant digits. But if you come back here to this problem, you might say, well, let's count the number of significant figures here. There's only 1, 2, 3, 4, because these trailing zeros aren't significant. I've seen textbooks that say that these may or may not be significant. You don't know. And that's one of the purposes of scientific notation. In other words, okay, if you have 3998, all right, now you want to round this up, okay? So you round this up, what happens? You get 4,000. Well, these zeros are significant. And you might say, well, let's just put a decimal point here. Okay, that works, but what if you have 3974? And you're not rounding the tens place here, because if you were rounding the tens place, you would say 3970. Right here we were rounding the tens place. But let's say you're rounding the hundredths. So this goes up, this 9 goes up, so you're left with 4000 again. But the decimal place is not here. There's only 3 significant figures here. So you see how it's confusing? Whereas if you have 3, 5, 2, 1, and this gets rounded to 4,000, right? Because the 5 rounds up to 4. Well, this has only 1 significant figure. So these 4,000s are different numbers as far as significant figures. And you see, you can't just put a decimal here. For this problem, you can. For this problem, you can't. For this problem, you can't. You can't put a decimal here. That doesn't make sense. It's not 4,000 anymore. And that's one of the purposes of scientific notation. I could write this as 4.000 times 10 to the third. I could write this as 4.00 times 10 to the third, and I can write this as 4 times 10 to the third. And if this is confusing you, don't worry about it. Go watch the video on significant figures, and then you can come back to this video. But anyway, so the idea is here we put 2.998 times 10 to the 10th So we know for sure there's at least 4 significant figures because we've got these 4 non-zero numbers, but we can't say whether or not these are significant. It's a guess. Only the person who presented this number in the problem can tell us if we should put a 0 here or not. Now, that situation with the trailing zeros ahead of a decimal is the only situation where you have that ambiguity where you don't know exactly how many significant figures there are. For every other situation, you can just count them. And so if you can count them, if there's no ambiguity, then when you write in scientific notation, go ahead and put the right amount of significant figures. So here we know, and again, we're going to talk about the rules of significant figures in another video, but there's only one significant figure here. These leading zeros with a decimal place don't matter, aren't significant. So we wouldn't, it would be incorrect to say 1.0 times 10 to the minus 5 centimeters. You would put 1 okay. For a test group of adult females between 18 and 20 years old, the mean blood volume was 4.2 liters. So they want us to put 4.2 liters in scientific notation. And so 4.2 is already between 1 and 10. So we just put the scientific notation representation of this number is this. Okay, don't forget to put the units. All right, now we want to write these numbers in decimal form. So 2.61 times 10 to the minus 6, you just move the decimal point over 6 units. So here we go 1, so now we've got 5 more movements to go, so there's going to be 5 zeros. 1, 2, 3, 4, 5. Okay. Okay, here we move the decimal point. We're going to have a larger number. The actual number is going to be larger than this here because we've got 10 to the second, so we move the decimal point over 2 spots. So 352. Okay, times 10 to the first, just move the decimal point over 1 to the right. So 67.18. Okay, here we move the decimal point to the left. We have a negative 1, so 1 spot to the left, 0.187. Okay, a drop of water has approximately 1.67 times 10 to the 27 molecules of H2O. All right. So in decimal form, we're gonna move over 27 spots. And so here, 27, 26, 25. So we need to move 25 more spots, so we're going to have 25 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And then put the number, in this case, the number means something. So you got to put what it means. Okay. Typical red blood cell is 7.0 times 10 to the minus 6 meters. I guess they're talking about its radius. So move the decimal point to the left, 6 units. So 1, that's minus 5 now. And then we've got 5 more places to go. So we're going to have 5 zeros. 1, 2, 3, 4, 5, 7. And then we want to get our significant digits right here. There's 2 significant digits here, so put a 0. So now there's 2 significant digits. We could put a 0 here as well. Okay, so now we're going to talk about what do we do if we want to add, subtract, multiply, or divide 2 or more numbers that are in scientific notation. Okay, so here, let's put this in scientific notation, this 145.75. So we've got 1.4575 times 10 to the what? Times 10 to the 2 power, so plus. Okay, how do we add these numbers? For addition and subtraction, we first express both numbers to have the same exponent, the same power of 10. Then we combine the leading terms. We just add or subtract them. And in the final addition or subtraction, the exponent remains the same. So then we've got our answer. We convert it back to the proper scientific notation form. So let's convert this to 10 squared. Okay, so plus, now if this is times 10 to the 2 power, what does that mean for this? So if we multiply this times 10 to the third, right? Because then 10 to the minus 1 times 10 to the third, it gives 10 squared, which is what we want. Well, to multiply by 1, we need to also multiply times 10 to the minus third. You see, because 10 to the third times 10 to the minus third is 1. So we combine these two, and we bring this 10 to the minus third over here. So we get 0.0023 times 10 squared. All right, so now we've got we've got two 10 squared. So what we can do is just add the two leading terms. All right. So we've got 1.4598, and then this stays the same. Okay? And if for some reason we got a number that's not between 1 and 10 here, well, then we change it to have the correct scientific notation form. But here, it's already in the correct form. So that's our answer. All right, so what about multiplication or division? All we do here, well, let's first write this in scientific notation. So 7.95 times 10 to the 1, 2, 3, 4 fourth divided by, okay, you can look at this this way. So we have 7.95 times 10 to the fourth. You can look at it like this. And so what we can do is just divide these two decimals, and then this is just a multiplication. So this 10 squared goes away, and you've got just a 10 squared in the numerator. So 3.18, but technically for significant figures, we would put, instead of 3.18, 3.2, because we just keep the smaller number of significant figures. Here we want to have 3.2, and then what? Times 10 squared. Okay, so let's convert this to, so each of these have two significant figures. So if we convert this to 10 to the minus 4, we would multiply by 10 to the minus 1 to get the 10 to the minus 4, and then times 10 to the 1. So this would be 7 times 10. Well, I've got to do the significant figures. So this would be 70. I want to put a decimal point here. Okay. And then we've got, all right, so these exponential terms are the same. So we can just say, what is 70 minus 8.0? 70 minus 8.0. This is, I know this is 62, but we can't keep this decimal, this trailing 0. We have to just write it this way, because this doesn't have a trailing 0. So we've got 62 times 10 to the minus 4, because the minus 4 doesn't change. Now this we need to rewrite because this is not scientific notation, we've got 6.2, we've got two significant figures, times 10 to the minus 3. So 1.0 times 9.9 is just 9.9, and we keep two significant figures, times 10 to the what? 10 to the 4th times 10 to the 6th. 6 plus 4 is 10. So we've got, what do we have here? This is 9.5 times 10 to the 1, 2, 3 minus 3 divided by 8.5 times 10 to the minus 3. So these cancel. 9.5 divided by 8.5. All right, and we keep the smallest number of significant figures between the terms that we're dividing or multiplying. So 1.17, that's rounded to 1.1. So 1.1, and I'm assuming they still want us to use scientific notation, so times 10 to the 0. Okay, this is 6.53 times 10 to the 2nd, and then 5.75 times 10 to the minus 8. Okay, so this 10 to the 2 and 10 to the minus 8, that's going to be, we'll have 10 to the 10 squared minus 8, which is 10 squared plus 8. So this goes away and you're left with 10 to the 10th. All right, now 6.53 divided by 5.75. Okay, we have three significant figures in both, so this would be 1.14. 1.14 times 10 to the 10th. And then this is already between 1 and 10, so this is our scientific notation. If this wasn't between 1 and 10, then we'd have to convert it. But this is the correct answer. Okay. We've got, so 8.5 times 10 to the what? 1, 2, 3, 4, 5. Minus 9.0 times. All right. 8.5 minus. So now we have the exponents are the same here. So we can just subtract 8.5 and 9. 8.5 minus 9 is what? Just 0.5. And this is the correct, as far as significant figures, this is correct, because we don't say, or negative 0.5. We don't say, well, we need these, this has two significant figures, this has two significant figures, so let's put a 0 here. Now we have two significant figures. We don't do that because we can't have more decimal point place digits, more digits to the right of the decimal point than any of these two numbers had, or than the least of these two numbers had. So we leave it like this, and then times 10 to the 5th. All right, the absolute value of this is not between 1 and 10, so we need to write this as minus 5, and now times 10 to the 4th. All right, 3.6 times 3.6. 3.6 squared. 12.96, but we want to write this with two significant figures, so just put 13. Okay? Times 10 to the, now minus 4 plus 6. All right, so what is going to happen to this 10 to the minus 6 and 10 to the minus 2? We've got 10 to the minus 6 minus 2 plus 2. So we're going to have, this is going to go away, and this is going to be a minus 4. All right, now 8.4 divided by 2.1. 4, but we want to put 4.0. Right, because we've got two significant figures times 10 to the minus 4. And this is between 1 and 10, so, or the absolute value of this is between 1 and 10, so that's our answer. All right, so in this problem, we've got more than one step. We'll do this multiplication in the numerator first, and then we'll do the division. However, how we handle the significant figures is a little different here. But again, there's a whole separate video on significant figures that goes into detail on all of this. But the idea is we don't want to do this multiplication, round this, then do the division and round again. We want to conserve all of the digits we possibly can, either manually or with our calculator, in all of the intermediate calculations, get the final answer, put the final answer with a bunch of significant figures, and then go back and manually count how many significant figures the final answer should have, then adjust the final answer. That's the idea. Okay, let's do this multiplication. So we'll multiply the 6.2 and the 4.4 first. $27.28. So we'll just write out all of these significant figures, because this is an intermediate step. All right, times 10 to the what? 10 to the 5th times 10 to the 22nd. 22 plus 5 is 27. Okay, now we've got... All right, now dividing 10 to the 27th and 10 to the 17th, this goes away and this goes to 10. 27 minus 17 is 10. Okay, now let's divide these two. So let's write out all of the significant digits. So 12.4 times 10 to the 10th. Okay, now let's come back and see how many significant digits the final answer should have. So in this multiplication, we had, 2 here, so we retain the lowest number of significant digits. They both have 2, so 2. And then we're dividing by a number with 2 significant digits. So this should have 2. So rounding, we get 12 times 10 to the 10. Okay, let's multiply the 3.8 and the 4.8. 18.24 times 10 to the, so 4 plus minus 2 is just 2. Okay, now dividing the 10 squared by the 10 to the minus 5, that's 10 to the 2 minus, okay, 2. Okay, so this cancels and this goes to 7. All right, so now 18.24 divided by, so 7.296. Let's write out all of the digits. 10 to the 7th. All right, now, okay, this, we had 2 significant digits come out of this multiplication. And then the division, 2 significant digits. So rounding this, we get 7.3 times 10 to the 7. And again, if you're confused about the significant digits, go check out that video. It might not be posted yet, but it will be posted soon. I'll try to remember to put a link in the description. But if it's not there, just YouTube search Abair Engineering significant digits or significant figures.